Hello, dummies. How are you all? Today, we're going to unravel the mystery of bits and bytes, those tiny unsung heroes that make your computer work. Imagine your computer as a toy factory. The toys are pieces of information it needs to process, like text, music, photos, and videos. To make these toys, the factory needs very small parts, like tiny Lego bricks. These little bricks are called bits. In other words, a bit is the smallest unit of information a computer uses. There are only two possible states for a bit: 0 or 1, false or true. This is called the binary system, which is where the famous binary numbers you've probably heard of come from. Humans learn the decimal system in school, which goes from 0 to 9. Now, back to the toy factory analogy. When you combine 8 of these Lego bricks, or 8 bits, you get a byte. A byte is like a box where 8 Lego bricks can fit. With these bytes, your factory can start building bigger and more useful things like letters, numbers, and even parts of an image. With many of these byte boxes, the factory can create anything, from simple calculations to addictive internet videos. If you've ever heard sayings like, "computers are so smart," know that this is completely wrong. Computers are the dumbest machines in the world. They only understand two things: 0 and 1. Without programmers, computers do absolutely nothing. You might be wondering now, if computers only understand zeros and ones, how is it possible to use letters and symbols? This is where the magic of encoding, or rather human ingenuity, comes in. Let's take a closer look at these 8 blocks. We can place a 1 or a 0 in each of these squares, right? There are 8 positions with 2 possible numbers in each position, so we can represent it this way: 2 to the power of 8. Solving this gives us a result of 256. You get 256 different combinations, with each combination representing a character or symbol. For example, this combination can represent one thing. That combination can represent something else. To standardize character representation and facilitate communication between systems, a system called Ascii was created. Each letter, number, or symbol is represented by a unique number between 0 and 127. For example, the letter A is 65 in decimal, which in binary is this number. Over time, we realized that 128 characters weren't enough to represent all the world's languages, emojis, and special symbols. So Unicode was created. It uses sequences of bytes to represent a vast array of characters. Unicode encompasses multiple languages and scripts. Breaking down linguistic barriers, it offers standardization, emoji support, compatibility, and extensibility. Humans created these encoding systems to translate the computer's language into human language. When you type a letter, the software you're using converts that letter into its corresponding ASCII, or Unicode value. That value is then converted into binary so the computer can process it. When the computer needs to display or use this data, it does the reverse, converting the ones and zeros back into the ASCII or Unicode value, and then uses a table to translate that back into the letter or symbol you see on the screen. Basically, it's as if computers are digital polyglots, speaking the language of binary but understanding and translating it into a language we humans can comprehend. If you have any doubts, leave them in the comments or feel free to visit our website where you'll find a contact section. Yes, this is therapy, $20. See you next time. Bye.